Let's try to solve this problem. So we have to ask ourselves, is this phase known or phase unknown? And to me, it looks like it's going to be phase known because nobody is deceased in the family. And we have the first generation parents having one child and then that child having a bunch of kids. So this looks like phase known. So let's see if we can solve this. The mom is going to have little d gene marker B and then a marker O like so because she doesn't have the disorder. So DD, no disorder, which is why she is not shaded in. And this person over here, we're going to assume that the disease gene is on marker A, and then a little d can be on the O. Like here, but even though it's capital D, lowercase d, the person is still shaded in because we are looking at a dominant disease. So now let's look at their offspring. This person's shaded in, so we know they had to have the capital D and marker A from dad, and they got their B from mom, so it's lowercase d, B. And the person they marry is homozygous, so they can only give this. So now let's rate the kids as recombinant or non-recombinant. So this person has the disorder, they are shaded in. So they had to get a big D A, and they did. So big D A, little d O, so this is non-recombinant. No crossover took place. And the same thing for these two. Non-recombinant, non-recombinant. This person is not shaded in, so they got a lowercase d, B from dad, and then a D, O from mom. They're not shaded in, this is normal, so they are non-recombinant. This person is not shaded in, even though they would have gotten the A marker, which would have meant that they had the disease gene. So what happened was recombination could have taken place where they got the lowercase d, and then the marker A, and then lowercase d and O. So we're going to rate this as recombinant. Here we have the same thing as this one, so it's non-recombinant. AO, they got the D, the capital D and then the A marker, so they're shaded in, so this is non-recombinant. And then we have a lowercase d and then the B marker, and then lowercase d and the O marker. No crossover took place, so this is non-recombinant. So now that we have everything, can make it stand out so we can count them. We can count how many we have. So for the non-recombinants, we have 1, 2, 3, 4, 5, 6, 7. The recombinants, looks like we have 1. So our total is 8. And now we can just plug into our equation. Log theta to the first, 1 minus theta to the 7th over 0.5. Our total 7 plus 1 is going to be 8. And now we're just doing the same thing as before, where we plug in for these values of theta, and we want to see if our LOD score is greater than or equal to 3. So let's plug in 0.05. So we take the log, our theta is 0.05 to the first, 1 minus 0.05 to the 7th, divided by 0.5 to the 8th. And we get 0.95. So after plugging in all of the values of theta, we get these values for our LOD score, and it looks like we don't have a LOD score that's greater than or equal to 3. So then our answer is no, the disease gene is not linked to the marker.